Hello and welcome to STR IAS. So in the previous lecture, we have seen about mantle. In this lecture, we'll be seeing the innermost layer of Earth called core, right? So core is divided into two layers, inner core and outer core. So till now we have seen the first layer is called crust. So after crust is called crust, and after crust we have mantle. In mantle we have core. In core we have, so this is called outer core and this will be inner core. So when it comes to core, first we'll be seeing about outer core. Outer core, it is between, we have seen like from here to here it will be around 50 to 70 kilometers. In oceanic crust 5 to 30 kilometers. Then from that, this is called Moho discontinuity. From there till here we'll be having 2900 kilometers. Outer core extension is from 2900 kilometers to 5100 kilometers. Then composition. So what will be the composition of outer core? So the composition of outer core is NIFE, nothing but nickel and iron. Nickel and iron. When it comes to composition, nickel, ferrous, and also some other trace elements will be there. So few elements will be there in this outer core. Then when it comes to density, we have seen the density of mantle. So what is the density of mantle? Please comment in the comment section. So density of outer core, it ranges from 9.9 gram per centimeter cube to 12.2 gram per centimeter cube. When it comes to mantle, so it is around 3.3 to 5.7 gram per centimeter cube. So it's of the lower mantle, not upper mantle. Asthenosphere is around 2.9 to 3.3, but the mantle which is lower mantle, it's around 3.3 to 5.7. We can see the jump from 5.7 to 9.9. So it's very huge jump, right? So when there is a very huge jump, we can also see that the temperature was 4000 degrees Celsius at mantle core boundary. So outer core temperature at outer core will be 4400 degrees Celsius, 6000 degrees Celsius in the inner core. In the inner core, the temperature will be 6000 degrees Celsius. How this temperature is produced? What are the forces behind this temperature? So forces behind temperature is latent heat of crystallization in the inner core, and also radioactivity of trace elements. So radioactivity of trace elements like potassium, uranium, and thorium. You can remember this, like what are the elements which are producing radioactivity, which is reason for temperature in the core. So it is potassium, uranium, and thorium, right? Then what about outer core? Is it solid or liquid? The outer core is absolutely liquid. The outer core is liquid. It's not solid just because there is no enough pressure. Density is very high, but there is no enough pressure, so it remains to be liquid or fluid, right? And there is one theory called dynamo theory. So this is a prelims focus thing. So according to dynamo theory, what this theory says is convection in the outer core. So convection which happens in the outer core. So we can see that in solids conduction happens, but in liquids or fluids convection happens. Solids conduction, right? Nothing but if you heat this layer by layer heating happens, and heat will flow towards the direction from high temperature to low temperature. This is called conduction. What about liquids or fluids? Convection happens. Nothing but if you are heating if you are boiling water, right? So it will go like this. This is called convection. So convection in the outer core plus Coriolis effect. This will be seeing in climatology. We're looking at climatology. What is Coriolis effect? So Coriolis effect is nothing but when something is revolving or rotating. When something is rotating, if you are trying to throw something in one direction, it will go in right side or left side according to the direction in which the body is rotating. So which we'll be seeing in more detail in climatology. Just remember, if something is rotating, so there will be, in childhood you will be playing with this on this, like in school. So if you are sitting here and if it is rotating like this, the clockwise direction, if you want to throw the ball A, B, C, D, if you want to throw the ball, if you are sitting here in the C, and if you want to throw the ball to A, it will be reaching to B, right? Like it will be reaching like it will be going on this direction because it is rotating in the clockwise. If it is rotating anti-clockwise, it will go like this. This is called Coriolis effect. So convection in the outer core and the Coriolis effect are the reasons for Earth's magnetic field. The most important thing to remember, right? Then we look at the inner core. So when it comes to inner core, so it is at the center of the earth. It extends from the center of earth to 5,100 kilometers. So we have seen outer core is still 5,100 kilometers to center of the, it is called inner. Then we'll change the color. So it is made up of, it is also made up of nickel plus ferrous. Nickel is iron is around 80% and nickel is around 20%, and it slightly rotates faster. So it rotates faster, inner core rotates faster relative to the surface. Okay, so this point they can ask for prelims. So inner core rotates slightly faster relative to the motion of the surface, and it is too hot and holds a permanent magnetic field. So it's very hot, and we have seen that inner core temperature will be around 6,000 degrees Celsius. And what about density of inner core? So outer core density we have seen 9.9 to 12.2. Inner core density will be around 12.6 gram per centimeter cube to 13 grams per centimeter cube. So there was a prelims question, PYQ. So they have asked inner core is made up of what in 2009. So inner core is made up of, the options are aluminum, chromium, then we have iron and silica. So inner core is made up of absolutely iron because NIFE. Fe is of 80%, right? We have seen this. Then scientists have determined that temperature near the Earth's center is around 6,000 degrees Celsius, and hotter than previously we thought, like 1,000 degrees Celsius. So 6,000 degrees Celsius is nothing but surface heat of the sun. So 6,000 degrees Celsius inner core temperature is equal to surface heat of the sun. So due to this temperature, so PV equal to nRT, ideal gas equation. When temperature is high, the pressure is also high. So when the pressure is high, it will become solid. That's why inner core is solid. So this is all about our 3 layers of the earth. So then we have something more to discuss. So we have seen that between the crust and upper mantle, the discontinuity is called Mohorovic discontinuity. We called it as Moho, right? Then between upper mantle and between the mantle and core, between the mantle and core, outer core, the discontinuity is called Gutenberg discontinuity. So this we can remember with crust and mantle, Moho discontinuity. Then mantle and core, we have Gutenberg discontinuity. Between outer core and inner core, we have Lehmann discontinuity. And between outer mantle and inner mantle, upper mantle and lower mantle, we have Repti discontinuity. So we have different types of discontinuities. Between crust and upper mantle, we have Moho discontinuity. Between upper mantle and lower mantle, we have URL, Repti discontinuity. Between mantle and outer core, we have Gutenberg's discontinuity. Between outer core and inner core, we have Lehmann discontinuity.